Okay, so we are continuing with 6.1, properties of exponents. We're going to look specifically at power of product and quotient properties. So what I mean by that is if we take a product and we raise it to a power, or we take a quotient for dividing things and we raise that to a power, what are the rules that we apply? So the power of product property states, let A and B be real numbers and let M be an integer. To find the power of a product, find the power of each factor and multiply. So as you can see, when you see that product, you're going to take each factor, in this case you have two constants, 3 and 2, and you're going to square them separately. Or not square them, but you're going to raise them to the fifth power separately. The power of the quotient property says let A and B be real numbers with B not, where B cannot equal 0, and let M be an integer. To find the power of a quotient, find the power of the numerator and the power of the denominator and divide. So again, as you can see here, they took that quotient and they took it to each separate numerator and denominator, raised it to the fifth power, and applied the division. So we'll see some examples here in a second. Do you have any questions about those powers, those power of quotient and power of product properties? You handle each thing separately and you apply the operation with our rules. So we know that when we take 3 to the 5th times 2 to the 5th, we're going to add those two powers. When I take 3 to the 5th divided by 2 to the 5th, I'm going to subtract those two powers. So here it says simplify each expression, write your answer using only positive exponents. So A, we have the quantity. Remember, the quantity refers to whatever is in the parentheses. So when I say the quantity, that's what I'm referring to. So I have the quantity negative 1.5 y squared. So according to my properties, how do I approach solving or simplifying this? Yes?
Add a 2 exponent to negative 1.5 and 1.
Yes, exactly. That's exactly what you're going to do. So, in this case, what I have is negative 1.5 squared times y squared. Doesn't really matter where you put the parentheses here. I want to be consistent. So, when you take negative 1.5 and you square it, you get 2.25. And then you have a y squared on the outside. Now it is important that when you separate it like this that you do leave parentheses. Here for B, we're going to separate them. So you have A cubed divided by what? Yeah, negative 10 to the third. Negative 10 to the third. And let me, again, just put okay, so we end up with A cubed on top and what on the bottom? What's negative 10 cubed? Not positive. It's an odd power, so it's what? What's the sign? Negative 1,000. Remember, 10, 10. You just add zeros. Raised to the third power, you have 3 zeros. So this A cubed over negative 1,000 is the same thing as negative A cubed over 1,000. Questions on that? All right, how would we approach C? I'll give you two options and you tell me which is correct. First or second one? Second one, yeah. You want to take both the 3 and the D and raise it to the 4th power. Here we don't really have any negatives, so using parentheses won't mess us up because we're just doing positive exponents here. But remember that the entire product has to be raised to that exponent. So 3D is a product. That has to be raised to the power of 4, both the 3 and the D. And in this case, you have 81 b4 over 16. And you want to check to see if you can simplify. Some of you on your last test, you gave me fractions that were not reduced. I didn't necessarily count you off, but you want to reduce your fractions. Okay, especially here, I will count you off because you are not simplifying. If I say to simplify and you don't reduce your fractions, then you will lose points. Now, with D, that can be a little tricky because we have a negative exponent. To handle the negative exponent, you can think of it in two ways. I'm going to teach you the easier one. They're both equivalent. What do we normally do when we have a negative exponent? Right, we're going to look at the reciprocal here. Normally what we do is we move it to the denominator, right? So what ends up happening is we would look at something like that, right? But that can be a little bit tricky. So we're going to do what Daniel just said and just look at the reciprocal and change it. Because when we do this operation, when we divide like this, we're going to end up with a reciprocal anyways. So that would be the same thing as 3 divided by 2x raised to the 5th. So anytime you have a negative exponent and you have division, you want to just flip it. You want to look at the reciprocal. So how am I going to rewrite this? You see this on the test, and I want you to simplify it. What would you do? What would you raise to the 5th? 3. What else? 2. What else? X. So everything's to the 5th. Can we subtract this? No. Why? Not the same base. We can't use our rules of exponents with division or multiplication unless they are the same base. So we're just going to have to mention 3 to the 5th. You can use your calculator if you need to. And then 2 to the 5th. So you'd end up with 243 over 32x to the 5th. Any questions? Okay, I'm going to show you an extra example here. You can just add this, make it E. Let's say we're to ask you to simplify something like this. Negative x over 4 squared. What would you square? The negative x. Since there's a negative, remember your parentheses, okay? So, negative x squared divided by 4 squared. What would that read? What would that simplify to? Would it simplify to this? Or would it simplify to this? Which one? Second one. Right. Why the second one and not the first? Because of the parentheses. You're taking the negative x and you're squaring it. So that's negative x times negative x, right? Which is a positive x squared. We cannot take that negative one out unless we do not have the parentheses, right? Does that make sense? Okay. Okay, if you're watching, go ahead and try these, pause, and I'm going to show the solutions. Oops, just kidding. So, this number 11, what would I do? What did you do? What? You can, that's one thing you can do. You can say 10 to the negative third times y to the negative third. Okay. Then what did you do? You stop there. You could just, what would you have to do with these? These are on the numerator. What would you have to put them? In the denominator. You could just have done that one, step 2. And end up with 10 to the third, and then y to the third. You get 1 over 1,000, 1 to the third. Yeah? Okay. The next one, we know we're going to end up with a negative here. And also, you know, for this fraction to be negative, only one of them has to be negative, right? So you can think of it like this if you wanted. You could put the negative with the n or the 4. Raise that to the fifth. So, what we're going to do now is we're going to, well, what are we going to raise to the fifth power? Negative 4? Right. So we're going to raise negative 4 to the fifth power, and we're going to raise n to the fifth power. What's negative 4 to the fifth power? Negative 256? Yep. Negative 256 over n. You getting these? What would we raise to the fifth power on 13? 1, which is still 1. What else? 2. What's 2 to the fifth? 32. And we're going to raise k squared to the fifth power, which is what? What's the rule here? Multiply them, right? When you raise a power to a power, you multiply them. So what do I end up with? K to the 10. Does that make sense? Okay, and then this one. Daniel said we just flip these around. So we have 7 over 6c squared. So we end up with what? 49 over 36c squared. 49 over 36c squared for number 14. Looking at all those, were they okay? Okay, nice. We're going to try something extremely challenging now. Alright, so we're going to approach this one parenthesis at a time. The first thing we want to do is get rid of our negative exponent, so what are we going to do with the x to the negative 2? Move it towards the top. So when we move it to the top, we end up with 3x squared y to the 0, or x squared, y to the 0, x cubed. And then I have 4, and then I still have times back here. So how can I simplify this even further? What can I combine? X's, what can I turn that y to the 0 into? A 1. So when I combine those x's and I turn that y to the 0 into a 1, what do I get? Three x to the what? 3. So we're not going to take care of the 4 yet. We're just looking at the parentheses without the 4. So we have 3x to the 5th. Okay, and then we have the y to the 0, which is just 1, so we're not going to have a y out there. But we still have that 4th power. Okay, we'll get there. So whenever I look at this, 3x to the 5th to the 4th power, what am I going to end up with? What am I going to raise to the 4th? 3. 3 to the 4th. So when I take 3 to the 4th, I end up with 81. So I have 3 to the 4th, x to the what? X to the 20. Remember, power to the power equals 5. So you have 81, x to the 20. Yeah? So that's that first side, so I'm going to write that in red up here. X to the 20. Any questions on that first side before we look at the second one? Yes. Well, there was a 3 right there. X cubed there. So when I brought this up, I have x squared. And I brought the negative 2 up. And I already had a 3 there. So when I multiply two of the same base with different exponents, I add those exponents and then have an awesome point. Yeah. Okay. Great question. Any others? These annotations. No. Let's look at the other side. And I rewrite the 81x to the 20. So when we look at this other side here, what am I going to do? What would you do first? Let's move stuff. Top and bottom. What will I move to the top? Y to the negative 8. What would I move to the bottom? X to the negative 4. So let's do that. We have a y squared. We have a y to the 8th. And then we have all of that divided by 5x, x to the 4th. And all of that raised to the 3rd power. What can I combine? The y's, the x's and y's, okay? This is kind of, I don't know why it's like jumping here, but y squared times y to the 8th is what? Y to the 10th. Y to the 10th. Y to the 10th over 5 x to the 5th. And you're raising all of that to the 3rd power. So what am I raising to the 3rd power? Y to the 10th. So y to the 10th raised to the 3rd power is what? Y to the 30th. And then I'm raising the 5 to the 3rd power, and I get 125. I'm raising the x to the 5th to the 3rd power, and I'm getting x to the 15th. Okay, that's the other side. I've still got that. But does this make sense so far?
add the two exponents?
Oh, you mean here? Yeah, we're gonna get there. But does up until this point make sense?
And like, and there were three, like, y to the 10th, but some of them add that.
Y to the 10th? Purple here?
Yeah, like, and then there's a y to the 10th.
That's y to the 30th. Because it was y to the 10th raised to the 3rd. Which is, if you have a power raised to a power, you have the 10 raised to a 3, and it's 10 times 3, which is 3. Because what we had was this. We had this. We end up with that. Now I'm going to rewrite that here, and then we're going to look at it all together. Do you have any other questions? Okay. Here we go. Y to the 30th over 125 x to the 15th. Let's say do it for tomorrow. Yeah, I realized that. I was hungry. Okay. Now we have to multiply them. So I'm just going to multiply straight across. We'll play more. 81 x to the 20th, y to the 30th, divided by 125 x to the 15th. I look and see if I can simplify 85 over 125. That fraction will reduce, it won't. But what can I get rid of? The x's, well, I can't get rid of them, but I can subtract them, right? So I still have 81. What will I have? X to the what? 5th, y to the 30th, over 125. Okay, do you have any questions? This one is not going to be on the test. Maybe a bonus. But I want you to at least see something like this. No. Silly goose.